We want to look at 2017 AMC 10A Problem 11. The region consisting of all points in three-dimensional space within 3 units of line segment AB has volume 216 pi. So what's the length of AB? And we have 5 options, A, B, C, D, E. So let me just draw my AB. So AB is this line segment here. Now I want the collection of all points 3 units away from AB. And the collection of my points are 3-dimensional. So we have a 3D coordinate system, Z, Y, and X. So it's 3-dimensional, and basically how we do this is we look at A first, we look at one endpoint, we look at A, and we figure out that, so we know that this point, let's just assume that this length here is 3, so this point is going to be 3 units away from A. Now in the X direction, here in the X direction, we have another point. Let's just assume that's also 3. So that point's going to be 3 units away from A. So every single point 3 units away from A meets our requirement, being 3 units away from A and B. So namely, every single point on this circle. So let me just draw the circle. So the circle here, that is kind of 3, like it cuts through. Like it kind of cuts through the side of the 3D plane. So every distance with every circle like that alongside AB is gonna have points on the circle that meets its requirements. So what I get here is gonna be like I get a cylinder. My radius of my cylinder is gonna be 3. So this is my cylinder. So that's my cylinder, and now basically I also want to figure out, I just want to check if there are any extra parts. For example, if I had this point over here and that's 3 units from B, however that point's not included in my cylinder, so what else do I have to add? So we should add another half of a sphere. So a half a sphere, just imagine that that's half a sphere. And we have this point here is gonna be B. So the radius of this half a sphere is also gonna be 3. Because if I have this point and I want the points 3 units away from this, I'm gonna, in a 3-dimensional space, I'm gonna get a sphere, right? So for this point, we still want a sphere, but it's half a sphere because the other half is included in my cylinder. The same thing happens for the endpoint A. So that's what happens. So I have 2 times 1/2 a sphere plus 1 times the cylinder. So we have 1 cylinder and 2 times 1/2 a sphere. So that's the area of this collection. So, or the volume of this collection of points that are 3 units away from line segment AB. And we know the volume here, so that's just 216 pi. So we're going to convert these words into numbers. So the volume of a sphere is, so first we can cancel out the fractions. So that's just 1 sphere with a radius of 3. So that's just 4 over 3 pi, and then r to the power of 3. So r cubed. So that's 3 cubed, which gives us 27. And we just add that to our cylinder. So our cylinder area is going to be, so our base area, our cylinder volume is going to be our base volume, our base area, which is pi r squared, which is 9 pi, times our height. Our height is going to be the length of AB, so we just write AB there. And that's equal to 216 pi. So I have this equation on the left side, and I can just factor this out and have 9, so I have 36 pi. In fact, I have 36 pi plus 9 pi. AB is equal to 216 pi. So, what if I just divide both sides by pi? If I just divide both sides by pi, then I'll get 36 plus 9AB is going to be 216. That looks way easier to solve. So we have 9AB is going to be equal to 216 minus 36, which gives us 180. So we just divide both sides by 9. We have AB is going to be 20. So that's our answer there, 20. So which answer choice is 20? Well, that's D. So the important part here in this problem is to visualize. We have AB, and we're going to visualize what 3D shape is my collection of all points within 3 units of the line segment AB. And we have to try to draw the graph and trial and error a few times. So thanks for watching.